Well, welcome back everyone. We're going to do a quick test here and make sure we have, there we go, the pen's working. All right, let's get going. The last time we talked about functions in general, we started talking about relations. Relations are just sets of ordered pairs, very general. Functions are special relations. And those are relations where every first coordinate has a unique second coordinate, or x and y's. Every x has a unique or one and only one y that goes along with it. Now, taking that one step further, we're going to talk about linear functions this time. So first of all, what's it look like? Here's what a linear function looks like. Right there. Now remember, this is just another way of writing y, but using this notation, outlines or bolds or whatever, the fact that we're talking about a function. And the linear function is because it looks like this. The important thing to note is that this is x to the first power, no fractions, no squares, no cubes, just x to the 1. The x has a coefficient. In this case, we're just calling it a generic a. We have a constant at the end. So this looks like y equals mx plus b. Does that look familiar? Or y equals ax plus b, whichever way you want to think about it. The domain and range are both all real numbers. Now let's look at an example. It says give the domain and range. Well, that's pretty simple. We've got a linear function. A linear function has the domain and range, negative infinity to infinity for the domain as well as the range. And that's typical, especially with linear functions. Now, what about the intercepts? Well, I'm going to write this function down here, and I'm going to write it with the y just to make things a little bit easier. So there's our function with y notation. If you want the x-intercept, remember, for the x-intercept, let the y be 0. So down here, that means we're going to put 0 in for y, and we'll find out what x goes along with it. So this is going to give us an ordered pair, 0 for y, and we're going to find out what the x is that goes along with it. The way I'd like to do it is add 2x to both sides. 2x equals 6. Divide both sides by 2, and there's the number that goes along with it. Y is 0. So there is the x-intercept. How about the y-intercept? Well, it's just the opposite. Let x be 0. So we'll repeat this. Y equals, get that out of the way, y equals negative 2x plus 6. That's our function, our linear function. And this time we'll put x in, the 0 in for x. So we'll have y equals, and negative 2 times 0 is 0. So you just have y equals 6. There's our second intercept, the y-intercept. Oops, there we go. Remember, for the x-intercept, put a 0 in for y. For the y-intercept, put 0 in for x. And that's basically what we already did. I may have given you an alternate look. Whichever way works for you is fine, but they're equivalent really. Now, why use 2, 2? Well, that's a good point. If you're graphing a linear function, if you get 2 points, you think, okay, I'll just connect those with a straight line, done. However, if you've made the slightest mistake and one of these is incorrect, then you got the wrong line. For example, if this one is in error, then this is correct, but you don't know where the line goes from there. So the best bet is to find the third point. If that third point is on the line, you're in good shape. Draw that straight line, and you've got your graph. If you graph 3 points and they look like this, you know at least one of those is in error. You need to start again. Probably with the x and y intercepts if possible, because they're easy to figure out. So use the point 2, 2 as a check, and there you go. Here were your intercepts, the y-intercept, the x-intercept, and one more point. How do you get that? Real easy, actually. Here's your function. F of x equals negative 2x plus 6. Pick any number for x that you like. Now, you've already done it for the y-intercept, so don't put a 0 in there. In this case, you put a 2 in there. So minus 2, and there's our 2 from this, plus 6, and that gives us 2. So this gives us a point 2, 2, which is right there. Since you can see they line up, it's almost a sure thing that this is a good straight line and the correct one. And the domain and range, as with linear functions, is the entire set of real numbers. So how about this one? This one doesn't look right to you. Is that correct? Well, actually, not only is this not complicated, it's actually easier than the one we just did. So what does this mean? First of all, give the domain and range. Well, what's the domain? Domain, all real numbers. You can put any number in here for x that you like. I'm just going to write it this way, but you could write it like this if you like, for all real numbers. Now what's the range? What y values will you get? Well, every time you put a number in for x here, the y value is still negative 3. So the range, we'll just rewrite this, the range consists of just one number, the 3. The y value in this function is always a negative 3. Negative 3. And a few comments. Hit pause and you can read those yourself. Notice that this is, of course, the same thing as y equals negative 3. Notice that y equals just a single number is a horizontal line. Very important. I'm going to come back to this later and give you a couple of tips. How about this one? Remember, the other one was f of x equals negative 3. This is, in some sense, the opposite. So let's take a look back here again. This is y equals negative 3. So if you were going to graph this and you didn't know initially that it was a horizontal line, you could get some points. Now what does this say? It says no matter what x is, the y value is always negative 3. So negative 3, negative 3, all of those are going to be negative 3's regardless of what you put here. Put a negative 4 there, maybe a 0, maybe a 5, and let's throw in a 7. And those should be in a straight line, and more than that, a horizontal line. So we're going to do something similar for, oops, I'm hitting the wrong one. My apologies. Okay, so it says give the domain and range. Well, you might think about what numbers can you put in for x and y. The domain is what you can put in for x. The range is what you can get out of the y. Well, this says x equals -3. How's that look? Well, it means no matter what ordered pair you have, the x value is always -3. So what's that look like? -3, -3, -3. X is always a -3. What's y? This is the rule for ordered pairs. All it says is every time you make an ordered pair, just make sure the x value is -3. Does it say anything about the y? No. So maybe -2, 0, 2, and maybe a 3. And you're in good shape. Remember, this corresponds to x equals -3. Think of it as a rule for creating your ordered pairs. So what's the domain and range? The domain, well, those are the x's. The domain is -3. The range is anything. So -infinity to infinity. You can use any of those. Now, because this is x equals, remember y equals 6, for example, gave us a horizontal line. X equals -3 will give us a vertical line. So you want to keep those straight. If it's y equals, it's going to be horizontal. If it's x equals, it's going to be a vertical line. And because -3 is always the x value, then you can just use x equals -3 and y equals 0 as your x-intercept. And if you remember it's vertical, you're finished. Domain and range. Domain has only -3. Those are the only x's. And the range is everything. Next. Now, we're going to agree that the coefficients and constants are rational numbers. That means fractions or better. Integers, whole numbers. The standard form is ax plus by equals c. Put it another way, the x's and y's are on one side, and a constant is on the other side. So if you do have it as y equals 7x minus 3, that's in slope-intercept form. You want the x and y's to be on the same side. So you can subtract the 7x from both sides. Get -7x plus y equals -3. Now you don't have to do this, but typically when you write this ax plus by equals c, typically this first term is positive. So what you can do is multiply through by -1, and you get 7x minus y equals 3. Now it says, if the greatest common factor is 1, they're said to be relatively prime. You don't have to remember that, really. It's a little bit of a trivia, but if you know it, it's handy. This means the biggest number you can divide into all three, a, b, and c, is a 1. In other words, you can't factor at all. They're relatively prime. That means compared to each other. Now, how about the domain and range of this one? First of all, we might find the intercepts. Well, that's going to be easy. Remember, x intercept, set the y equals 0. For the y-intercept, set the x equals 0. So get those intercepts. Let the x be 0, y is 0. So, what happens when we let y equals 0 to get the x-intercept? We've got the same point. We're not going to be able to graph it with one point, so you have to get another one. The origin is 1 point. You have to have a second one. Better yet, a third one, so you're sure that, or pretty sure, that you got the right line. You need an extra point to graph that function, because all you got is the point 0, 0. So pick something for x. In other words, oops, a little crooked there, but so we've already got the x and y intercepts are the same thing. And just pick something for x, anything you like. And they picked a 5, and then you find out what the y value is that matches with that. So you solve that equation. So you put the 5 in, simplify, solve for y. So that gives you y of 4. So that gives you 2 pretty easy points. Graph those. A better bet would be get one more. So pick something here, and of course this will be determined once you pick the x value. The domain and range, as with linear functions, are both all real numbers. And there's your point. There's your graph, excuse me. So there's 0, 0. There's 5, 4 that we found here. And it's a good idea to check with another one. Put 3 in for x. Find out what the y value is using that equation. And you've got a third point. If they line up, connect the dots with a nice straight line. Okay, now we're going to talk about slope. And slope is how steep a straight line is. We're talking about linear functions, so they're lines, and they can go at different angles. Slope is a way of saying how steep are they, and not what angle they are. We're not talking about trigonometry. We're not talking about geometry. We're only talking about how steep it is. And the way we do that is we take the x coordinates and subtract them. This 2 right here just means it's the x coordinate for the second point. This means it's the x coordinate for the first point. Subtract those, and you've got what is called delta x. Delta means what's the change in x. And the change means you subtract the 2. Now for the y values, you subtract those. The important thing to remember is whatever way you're subtracting these, you have to subtract the y values in the same order. If you've got the second x coordinate minus the first x coordinate, then you must subtract the second y coordinate minus the first y coordinate. And since this is delta x, this will be delta y. And that's going to give you your slope, because the slope is the ratio of those two. Here's the formula, and m is what we typically use to represent the slope, m. And that's the rise over the run, which means if we've got a line here, for example, and we're going from one point to another. This is point number 1, it's called A1, and this, it's called P1. That's better, right? And let's say this we'll call this point 2. Each one of those has an x-coordinate and a y-coordinate. If we want to find out what the slope of this line is, how steep is it, then we'll take the rise over the run. Well, what does that mean? Well, if you were at point P1 and you went to point P2, you would be going a bit in this distance. That would be your delta x, how much the x coordinates are changing when you go from P1 to P2, and you've got a change in the y coordinates. And you subtract to get those two values. Remember, subtract them in the same order. So over here, y sub 2 minus y sub 1, x sub 2 minus x sub 1. Notice that these are from the same point. These are from the same point. Now an alternate would be if you accidentally did it like this, if you subtracted y1 minus y2 and x1 minus x2, that would still be okay. It's still going to give you the slope. The important thing is that these come from the same point, P1 in this case, and these come from the other point, P2. So these come from one ordered pair, these come from the second ordered pair. It should go without saying that what you have in the bottom can't be 0. You can't divide by 0. And this is basically what I just said. You can pause and read through that if you like. So you can use either of these you like. Second point minus first point, or first point minus second point. Either way. Just don't mix these up. Notice these two are not from the same point. Don't do that. Be careful. Undefined slope, a vertical line. Now this is very important. The slope of a vertical line is undefined. And we're going to add one other thing to that. That vertical line is going to have an equation that looks like this. And we'll just throw in a number here. Let's say x equals 5. So 3 things to glue together in your head. Vertical lines have undefined slope, and their equation is x equals some number. Keep those 3 together so that if you see x equals, let's say 15, you know immediately that the slope is undefined and it's a vertical line. It makes things much faster, and it also puts together those concepts that are supposed to be together. So let's take a look at this. What's the slope of the line that goes through those given points? Now what I'm going to do is I'm going to call this point 1, and I'm going to call this point 2. So if I were traveling, let's put me here. I'm traveling from point P1 to point 2. How difficult is that travel? Well, let's see. We're going to find the slope. First of all, it's going to be a ratio. Second, I'm going to be subtracting coordinates, so I can put those in. Make it real simple. You got it perfect so far? Now, on the top go the x values. Or excuse me, that's not right. On the top go the y values, because this is going to be delta y on the top, it's going to be delta x on the bottom. So, I'm going to take the y coordinate from the second point, y2, and I'm going to subtract y sub 1. What's y sub 2? Well, this is point number 2, and its y coordinate is -3. And I'm going to put these in parentheses because I don't want to get mixed up between these minuses and the negative numbers. That could be confusing. Now, as soon as you've written in this second y coordinate, right away say, okay, this number right down here has to be from the same point. So negative 3 has an x coordinate of 2, so put the 2 there. So right away, these two are a match. Now we'll go to the other point. Y sub 1, that's the first point. The y coordinate is 8. Don't have to, but we'll put that in parentheses just to be safe. And what is the x coordinate of point 1? It's a negative 4. Now, especially with these negative numbers being parts of your coordinates, this could be a problem if you're not careful. Doing what I did with putting parentheses around the actual coordinate values helps you a whole lot. Now, let's see what we've got. On the top, I'm going to take this one little step at a time. I've got minus 3, and subtracting 8 is, I'll just leave it like that. On the bottom, 2. Now we're subtracting a negative 4. So these negatives cancel each other, so actually we've got 2 plus 4. There's where these parentheses can be a big help. You might have accidentally taken 2 and subtracted 4, and of course that wouldn't be correct. So what do we get? We'll just come on down here. Minus 3 minus 8 is negative 11. 2 plus 4 is 6. And there's your slope. Now, what does that slope tell us? Story. And we get that story from the slope. First of all, you see that it's negative. That means that our line is going downward. As we go from left to right, it's going downward. And that's what that negative tells you. Also, the fact that it's 11 over 6, which is almost a 2, means it's on the steep side. If I were going at a 45-degree angle, 45 degrees, then this would have a slope of negative 1. This is even steeper than that. So it's probably more like that if you actually graphed those 2 points and connected them with a straight line. So the slope tells you, is it going up as you go from left to right, or is it going down? This says this one is going down. The 11 over 6 says it's pretty steep. Moving on. And they worked this out just as we did. Here's another one. Find the slope of this one. Remember, the y's go on the top, you'll be subtracting them. The x's go on the bottom, you'll be subtracting those. Make sure that when you find the slope, these come from the same point, and these come from the same point, and you're subtracting, you're not adding. So there's your second point. There's your first point. We're subtracting them. And there's our number. Well, actually, it's not a number, is it? If you tried by mistake to put that in the calculator, you'd see that the calculator doesn't care for that because it will not divide by 0. It's impossible. It's undefined. So that means, remember when I told you those 3 things that go together? X equals 6 is a vertical line, and slope is undefined. I guess I should add this. Vertical line. These 3 go together. If you can keep those together, if you see any one of those 3 statements, you can think of the other 2 immediately. It'd be a good idea. Okay, can you do this one? How about hitting pause, try this yourself and see what you get. All right, you're back. There's our subtractions. This time we get a 0 on the top, which is fine. We can divide into 0, just not by 0. Now, what does that mean? We've got a slope of 0. Slope of 0 should tell us immediately we've got a horizontal line. What else? It looks like this. Y equals some number. In this case, a -3. Those three should go together. The slope of 0 is a horizontal line, and the equation looks like y equals some constant. Keep those two together. That's really helpful. So slope equal to 0. The slope of the horizontal line is 0. What else do we know? We also know that the horizontal line is going to be y equals whatever. What's the slope of this line? Okay, well, go back through your archives, recheck your notes perhaps. How do you figure that out? Well, first of all, you're going to solve it for y, because if you solve it for y, that will put it in slope-intercept form. Hey, slope-intercept form, that means when you find out what this coefficient is of x, you've got the slope. It's done. So, solve it for y. Get rid of those x's. We're closer. Divide by 3 to get 1y. Put in slope-intercept form, and there's the slope. Now remember what I just said. The slope of -4/3, I'm missing something here. Lost my pen for a second. Okay, the slope is -4/3. What does that tell us? Number one, because the negative, it means it's going downhill. 4/3 means it's a little bit on the steep side, not terribly steep. That should give you an idea of what the line looks like. And because this is slope-intercept form, you know that it crosses the y-axis at 4. And it's a bit steep, so it looks something like that, roughly speaking. So you can do that part in your head. So when you actually graph it, or using your graphing calculator, you can get an idea of what it should look like. And if it doesn't look like that, then you see where you made a mistake. Now how about this one? This is something that you can do, but maybe you haven't done before. So what you want to do is you want to graph this line. So we're told that it's a line, and we're given two things about that line. Here's one of those points, those many points that it goes through. And we also know that the slope is -5/3. Right away you ought to jump and tell yourself, oh, it's going downward from left to right. And it's a bit on the steep side. But how can I get the actual line? Well, this isn't really the greatest. You can do better. But this will give you an idea of how to do it. All right. Right off the bat, you got this point. Let's put that in. -1, 1, 2, 3, 4, 5. There is 1 point. You got it already. Got one already. You need at least 2 more points. And the slope is going to help you get those other points. Remember, the slope is -5/3. And I'm going to put that negative either on the top or on the bottom. It makes things a little bit easier, okay? So remember, if this negative is on the outside or in front of it, put it on the top or on the bottom. Now, the second thing is, what is a slope? It's how the y changes while the x is changing. So here, this gives us a little bit of an example. If I go a -5 in the y direction, I should go a +3 in the x direction. So I know this point is on the line. So I'm going to start there, and a -5 in the y direction would be 1, 2, 3, 4, 5. And if I do that, then I'm going to go +3 in the x direction, which puts me one, two, yeah, there we go. So there's another point. We go -5 in the y direction, +3 in the x direction, and we've got another point. We could graph this right now, but let's be a little bit more careful. Let's do this again. We're going to go from this next point, and we're going to go -5 in the y direction, 1, 2, 3, 4, 5, and then we go -5 in the y direction, 3 in the x direction, and there's another point. We've got 3 points, and if you eyeball it, even on my graph, it looks as though they're lined up. So get your straight edge, which I don't have here. Connect those with a nice straight edge, a little bit better than I did. And what you might want to do is, if you knew what this line was, you could actually write it with the proper slope and y-intercept. Okay, so that is how you graph it. Start with a point and let the slope with a minus, if it has a minus, either on the top or on the bottom. This tells you how to go from that point to another point. And then if you want a third point, just do this again. Go this in the y direction and this in the x direction. You've got a new point. And that's what it should look like. And that's basically what it looked like to us. Except that I went a little bit further and I got an extra point down here just to make sure that if I made a mistake that they're all on a straight line for sure. If they're not, I'm going to go back and start over again. So I've described this a little bit before. So first of all, think of this as you're reading a line. So you're looking at the line, you're eyeballing it from left to right, just as the way you read. As you're going from left to right, is it going up or is it going down? If it has a positive slope, then it is going up. If it has a negative slope, then it falls down. If it has a slope of 0, it doesn't go up or down. It'll be that vertical line. Remember, it has a slope equals 0 and y equals some number. And last of all, if it's a vertical line, the slope is undefined. Good things to commit to memory. I'm not a big person on memorizing things, but when I suggest that you memorize something, it's a real good idea, okay? So go with me on this. Now, we're going to talk about something a little bit different, and at some point you're probably going to forget average rate of change. The important thing here is you're going from one point to another. You're going from an x of this value to an x of this value. And what you want to do is you want to find the rate of change, also known as slope, when you're going from A to B. Those are x values. Like going from 6 to 10, for example. Now the way you do that, remember you got 2 points. You got one point that has an x of A. You got a second point that has x of B. Well, what are the y values? Well, the function is going to tell you. We've got a function f that we're talking about here. So what is the y value? It's the function value at A. What is the y value that corresponds to x equals b? It's the function value at b. In other words, for this one, put the a in where the x's are, evaluate your y. For the second one, put b in your function where the x's are and find out what that y coordinate is. So if this is your first x coordinate, this will be your first y coordinate, second x coordinate, second y coordinate. Okay, let's get to a little bit of an example so maybe you get a better idea of how this actually could be used. And we're going to pretend we're in the Amazon world. Not the Amazon in Brazil, but the Amazon in the United States. So we want to find out, we want to graph this as a line segment and interpret the result. Now notice first of all that 2013 and the $6,565 million are an ordered pair. The 2017 and the $22,620 million is a second ordered pair. So how do we graph that as a line segment? Well, the 2013 and this number are an ordered pair. And there's our first ordered pair. The second set, 2017, 22,620, that gives us a second ordered pair. What's next? Graph those. Make sure that you start over here with your first year, maybe end with your second year, or maybe a little bit beyond if you like, and graph those with appropriate constants. This bottom right here should ordinarily be a 0. Notice this goes by 5 thousandths to make it easy because you're graphing some pretty big numbers. So 5,000 might be a good way to use as your unit in the y direction. And there's your line. Just find those 2 points on your graph, connect them with a straight line, and you've got a line segment. So what it shows is that it has a positive slope. That's good because it is going upward. And if you own Amazon, you want those sales to go upward. The annual amount increased by an average about 4,014 every year. Why? And that's the slope. And the slope you can think of as a rate of change. That's how the sales are increasing per year. sales. In this example, it's sales per year. In different applications, these two would be different, most likely. Here's one that says finding the average rate of change for a nonlinear function. In other words, we've got 2 points here. It's not a straight line, like it usually is not in the real world. But we can find the average going from this point to this point. What's the average change per year? We can just do the slope, 2000, 2017. We can make this a little bit easier if we start with the year 2000, then this would correspond to an x of 0, making the numbers easier to work with. And this would be, excuse me, 17 years after 2017. And you've got the costs here on the graph. So the average rate of change is the slope of the line that we're making from those 2 points that we're aware of. And that slope is 134.3. And notice that it's positive. It's going upward. You can tell that from the graph too. Those should match. This being positive and the line segment going upward as you view it from left to right. So healthcare is increasing by an average, not exactly, but an average of $134.3 billion per year. I'll let you consider what that means. Now, this is very important. Some of you might end up going to business calculus, for example, or maybe something similar to this. The linear cost function has 2 pieces to it. Now remember, a linear function looks like this. F of x equals ax plus b. In this case, we're looking at the linear cost function, so we're talking about a particular function. And this cost function says, okay, at the very least, it's going to cost B dollars or B euros or whatever it is. And then you've got whatever you're producing. The X represents how many of those things you're producing. If you're talking about televisions, then X would be the number of televisions you produced. And this A represents how much it costs to make each of those televisions. And B represents what's it going to cost even if you don't make any televisions today. Because remember, you're going to have to pay the employees, you're going to have to pay insurances, you're going to have to pay heating and lighting, all that sort of thing, regardless of how many TVs you put out today. This is going to vary according to how many TVs you make today. This is not going to vary. So this is variable, this is fixed. That's what all this represents. I'll let you read through this. It basically says the same thing. Now that was a cost function. We've also got a revenue function. What are we talking about? Okay, we're producing something. Let's say we're producing TVs. Why are we producing the TVs? We're going to sell them, right? Okay, so in producing those TVs, it's going to cost us something to make them. That's what the cost function means. The revenue function represents how much money comes in because you're selling them. You're going to sell them for a certain price, and you're going to sell a certain number of them. And here's the function. The revenue is the price times the number of items you're selling. So if you sold 7 TVs and you sold each one of them for $300, how much money would be coming in? Your revenue from the 7 TVs would be 7 times 300. Actually, if we go by this, put it this way. The price of each one times how many we're selling. So our revenue from selling the TVs would be $2,100. That's how the revenue function works. Remember, the cost function is money going out. The revenue function is money coming into you. And the profit is how much you're making by this. And if you think about it, if you take that revenue, that's how much money is coming in, and you subtract what you have to pay, that's what you're writing the checks for, the profit is how much is left over for, if this is your business, do you have enough money so you can go to Acapulco or somewhere on Christmas vacation? The more this is, the more you can spend on vacation. Okay, backtracking one more time. This is the money coming in. This is the money going out. This is what you get. And of course, if this gets too big, if this is more than the revenue, you're losing money. Profit means you've made money. If it ends up being negative, you've got a problem. Here's the profit function. Profit equals revenue minus cost. Basic. So let's look at an example. Suppose the cost to produce an item is a linear function. Let's keep it simple. And all items produced are sold. Good. So we make them, we sell them. The fixed cost is $1,500. Variable cost per item is $100, so whatever it is. So first of all, what's the cost function? Well, right off the bat, we've got a fixed cost of $1,500. So even if we don't make any of those products, we still have to pay out $1,500 for this month or this week, whatever it is. Assuming we are making some of those, each item that we make costs $100. So if we make X items, it'd be 100X. This is the variable cost because it depends on how many of those items we're making. This is fixed because this will be the same for every day, month, year, or whatever that you're talking about. There's your cost function. It looks like this with the numbers put in. How about the revenue function? Remember, the revenue is the money coming in. You're selling these things. Each one of them you're charging $125. And you're going to sell X of these items. So what's the revenue function? Price times X is the revenue function. That's a good one to keep in your head, or at least in your notes. Put the numbers in. We don't know how much we're going to do this, let's say today, but we know each one of them we're going to sell for $125. The more of these items we sell, the more money is coming into our cash register. How about the profit? Well, remember, profit equals revenue minus cost. So we'll take those two functions, put those together to make the profit function. Here's the revenue function right here. There's the cost function right there and the subtraction between them. And if we simplify it, there's our profit function. A real good idea to use the parentheses. If you don't use the parentheses, you might forget that this has to be a negative $1,500 because you have to subtract the whole cost function to get the proper profit function, of course. Now it says how many items have to be sold for the company to make a profit. Well, if you roll back to where I was talking about the profit, you want that profit to be positive. In other words, you want the P of X to be bigger than 0. If it's 0, you're breaking even. You're not making any money, but you're not losing any money. I guess that's good, but it's not so good if you want to go on vacation, right? So how many items must be sold for it to make a profit? Well, this means you're making a profit. So it has to be positive. So here's our profit function we determined a few slides before. That it has to be positive. So take this, put it in there. We've got an inequality. Why an inequality? Because if you sell, say it took 600 to make a profit, 700 would make a profit, 1,000 would make a more profit. They're all profits. So we have an inequality because the more we make, the more profit we're going to get. Solve that. Divide the 25 into both sides. Notice you're dividing by 25, so this inequality that you see right here is not going to reverse. This is a positive 25, so this greater than stays greater than. Now what does that mean? Always go back to the question. What does that mean? How many do you have to sell or make to make a profit? And this says if you make more than 60, 60 won't do it, more than 60, you're making a profit. Which means come Christmas time, you can take time off and you can go on a vacation because you made a good profit. So at least 61 items. Now, why does it say 61? Think about it. Let's say you are making and selling TVs. Well, this says you have to have more than 60. But can you sell 60.7 TVs? No, that doesn't make sense, right? So it has to be 61. Keep in mind, we're talking about a real question, a real answer. So don't give something silly. Now, if we were talking about how many pounds of something, you might be able to do that. You might have 60.7 pounds of something, but you can't have 60.7 TVs. So think before you put your answer down. Okay. Tip for the day. This is my slide that I made up, and this is what I mentioned before. I want you to keep these 3 facts glued together in your head. So if you see something that says a slope is undefined, immediately think, oh, that's a vertical line. And the equation is going to look like x equals some number that you can figure out. On the other hand, if someone says, I've got an equation that looks like this, y equals 7. What 2 other things does that tell you? It's a horizontal line, and the slope is 0. Well, that's it for this time. I hope you stayed awake the whole time. We'll see you next time. Until then, you take care.